Thank you all. Today I'm going to be talking about a participation grade and specific strategies for grading clicker questions and how to incorporate clicker questions into an overall grading scheme. Just as a quick introduction myself, I'm Dr. Sarah Edwards. I'm an instructor at Western Kentucky University in Bowling Green, Kentucky. Fantastic institution. We have a beautiful new science building. It is a great place to be. I've been using iClicker for as long as I've been teaching. The idea of I ask a question, show them how to do it, they answer the question, it is just how I teach chemistry. And it's a very effective tool for getting that chemistry into the students' brains, which is the overall goal of teaching. An overview of what I'm going to talk about today. I'm going to talk about two different strategies for putting a participation grade in an overall grading scheme. One is for a Gen Ed course, which is Science for Citizens, Chemistry for Poets. It is a science class for non-science majors, which totally valuable thing that is a joy to teach, but it's a very different population and a very different pedagogical strategy than what I might have for a chemistry, biology, physics major. Then I'm going to talk about how and why to grade clicker questions based on whether or not they are correct or not. There's one philosophy, well, I'll talk about this in more detail, but there's one philosophy that says don't test them on something that they have just learned, but we'll talk a little bit more about that. As a disclaimer, everything I'm talking about, everything that this presentation is built around, is questions for which there is a distinctly and singular correct answer. Anything numerical for which there's only one numerically correct answer, or things like models of the atom, diagrams of the cell. This is not for creativity or composition, construction-based stuff. It is for algorithmic, yes or no, true or false, right or wrong type question. The overall goal is to reward the behavior that you want. The behavior that I want is right answers. So by giving more credit for right answers, even in the classroom, in the participation setting, it is a fundamental truism of mammalian behavior that if you reward a behavior, you get more of it. So by bringing attention and making it hurt just a tiny bit, if they don't get the right answer, really drives home, okay, what did I do wrong? I need to get that extra point. It brings more attention to the problem-solving process. So here's a scheme for participation in a general education course. 1,080 points possible. About 50% is based on activities, whether it's homework, labs, or the clicker questions themselves. And about half is assessments, whether it be a comprehensive final or one of the unit quizzes. Key critical thing here, participation is worth more than 10%. A preponderance of years and years of anecdotal evidence based on conversations I've had with anybody who will indulge me on talking about academics and pedagogy. If homework is not graded, it is not done, and if it is worth less than 10% of the grade, I don't care. So even that extra 4%, that extra fraction of a percent, really makes it mathematically more valuable, but also gives it more weight. And by having participation that is done in the classroom through a polling response system like iClicker, it brings students to the lecture hall, which in a non-majors course where they only really need the C in a terminal course, it really brings them into the classroom to get more chemistry in their heads, or more of whatever the subject is. I'm a little biased to chemistry. In a majors level scheme, for chemistry, it is a big glaring omission that there are no labs in this scheme. At my institution, labs are a separate course, a separate CRN. So labs are 100% of the grade of a different class. But we have participation and homework assignments. Activities are worth 25% of the overall grade, and assessments are worth 75%. And this 25% comprehensive final, that is an administrative thing that we use a standardized final, and it's a whole thing. But assessments are 75%, activities are 25%, with once again that participation being over 10% of the grade. Not massively over 10%, but enough over 10% to get that attention. And it's a standard grade distribution where 90%, 80%, 70%, ABC. Nothing too crazy. And this is just a lesson learned the hard way by myself. Grades are based on point accumulation, not weighted percentages of anything. If it is purely based on point totals, it's a much cleaner discussion at the end of the semester, rather than, is the weighting done correctly, rounding errors, total up the points, be done with it. So there are some pros and cons for grading participation for correctness. The pros: it is constructive and instant feedback. They don't have to wait to get the answers back for a graded test. I put the question up on a slide, they answer it, I tell them the correct answer, and work through whatever process that is. If it's an algebra-based problem, which probably 80% of the chemistry problems are, I simply work through it in the class. If it's which statement is true or false, I go through each statement and ask for a volunteer to say, all right, this is a false statement. Somebody change it to make it true. So it's all the concept-based questions can also be triggers for discussion, particularly if you have those really good foils that everybody, if they're not reading carefully enough, or that common misconception that isn't necessarily a lack in my teaching, but a fundamental confusion in the nature of matter and life, the universe, and everything. So the questions can also serve as discussion launchpads. And that instant feedback, they know immediately, was it right or wrong? Critical. Students crave and love instant feedback. So much so that if the way REEF looks, you can put up a histogram of what the answers were. It's ungraded until you click on the bar that is the correct A, B, C, D, or number answer. If I say the correct answer was B and then move on, they'll say, no, go back and grade it. Because the blue bars will turn green for the correct one, red for the wrong ones. They really, really want to see those colors change. This surprised me, but without fail, if I move on without clicking the right answer, and if I did, I can grade it later, students crave the instant feedback that clicker questions provide. And if that feedback is, this answer is right, and therefore you get more points, that's useful feedback for them to have. It's that reward. It also reinforces the learning. Again, questions can serve as launch pads for discussion, particularly if I see a distribution of answers that is almost even. I know I need to stop right then and talk more about that question. And if I'm feeling generous, I will not grade that one, talk more, and give them another crack at it. So there is an element of just-in-time teaching where if it's a very poor question, I can pause and talk more about it. So it reinforces their learning and my ability to teach. It also keeps their attention. They'll bring their cell phones to class. I don't have the physical presence or the desire to police cell phones, so it's just a fact of life that they're going to have a cell phone with them. I might as well capture that device and make them do at least a little bit of chemistry on it. So Reef Polling is an app that they just log into on their phone. It takes about 2 minutes to set up. And they don't see the question on their phone. So they have to be in class to see what the question is. They have either a field where they can enter a numeric answer or an A, B, C, D option. So they don't know what the question is unless they're in that room. They answer it, and then they will see the question later. So it serves as a study guide for them. And they can go back and study from it. So they have to be in class to answer the question, so it brings them to the lecture hall where at least some of the learning is happening. It also forces them to log out of Facebook for at least a minute or two every few minutes of class, to log out of Facebook, log into iClicker, answer the question, and then, they're answering the question, so they're thinking about chemistry, which that's what I want them to be doing during that lecture time. Now, some of the cons. There is an argument, a very strong and very reasonable argument, to be made against testing on something, because that's very arguably, what I'm doing when I ask them a question that I don't tell them the answer to ahead of time. I'm testing on something they just learned. So that's, some of my colleagues don't grade for correctness for that reason. However, I combat that using the I do, we do, you do model of problem solving. So every time I present, whether it be a limiting reactant problem or a mass to mole conversion, some algorithm, some method of problem solving that is ubiquitous in my field. I do the problem entirely on the board, so they see how it's done. Then I ask a more open-ended question, and then I set it up. So if it is a limiting reactant problem going from grams of one substance to grams of another, I'll say, the first thing you need to do is convert this to this. And then they finish it out. Third question will be multiple choice, where they have to do the entire problem, start to finish, on their own. That sort of phased-in approach takes a little bit of the pressure off instantly having to know how to do a problem, and it helps build their knowledge. Another argument is it's a little harsh. So I don't grade the problems entirely on correctness. Each question is 1 point. If they answer the question, they get 3/4 of a point. If they answer it correctly, they get a full point. So I won't give an A for effort in a college class, but I'll be kind and give a C. And what that does is it's not so demoralizing that I'm coming to class, but I'm failing my participation grade. First of all, I'll show some data that says that doesn't really happen. But it kind of eases that harshness of the, instant testing. So what we have here are some grade distributions of participation grades using this, and this is just the participation fraction, so that, 12 to 14% of the overall grade. As we see, we have different distributions between my majors and my non-majors. My majors, this is a course of 30 students, so like 2/3 get an A in participation, about what I would expect. And there's a vast drop-off and a slope down. So the vast majority of the students get an A or a B. Only 2 students got zeros. And there's a deep correlation between that very low grade and a lack of attendance. So another correlated benefit to grading participation is it serves as an attendance record too, which is a useful thing to have. Because if a student comes and says, "Why is my grade so low?" Well, you don't come to class. I have an absolute record. And it's amazing how when I send out alerts saying, grades are updated, I suddenly see students come back to class when they realize, oh yeah, participation, it matters to my grade. So it absolutely brings them into class. There's a more pronounced effect with my non-majors course, but again, my majors care about the class already. The non-majors, maybe not as much. In my non-majors class, I see the same, in a 55 student class, most of my students still got A's, and the vast majority got A's or B's. This little spike at the F's, those are the students that weren't coming to class. If you got a 0 in participation, you were not in the classroom that day. And I don't want to get too much into discussions of cheating because, it's a fact. You can answer remotely, unless you turn on the GPS feature, which I'm not Big Brother. I don't want to do that. So yes, there are mechanisms for getting around, but it's going to be reflected in your grade because you have to at least be paying attention during the class hour enough to know when I've asked a question. So most students who aren't going to come to class in the first place don't bother doing that. So it's a very effective mechanism for getting students into the classroom. So again, the take-home message is reward the behavior that you want. I want students to get the correct answers on these problem-solving numeric factual questions, so I give more points for correct answers.